And welcome to another class. Today we are going into logarithms and we are going to go into details of logarithm. What is logarithm? Logarithm is another word for power. Actually, the logarithm of a number is the power to which 10 is raised. Is the power to which 10. The logarithm of a number 1000 is the power to which 10 is raised. So if we have something like this, it means 1000 is equal to 10 raised to power what? The logarithm of 1000 is the power to which 10 is raised to give that number. And what is x? X will be 3. It means x in 3 places. The logarithm of 1000 is the power to which 10 is raised to give that number. 10 is raised to 3 to give 1000. So if we have something like log 100 is the power, log 100 is the logarithm of log 100 is the power to which 10 is raised to give that number. 10 is raised to give 100 in 2 places. So 10 raised to power 2 equals 100. So we can say another word for logarithm is power. Another word for logarithm is power. For instance, let's have something like this: power and then log. If we have 1000 is equal to 10 raised to power 3. We have 100 is equal to 10 raised to power 2. We have 10 is equal to 10 raised to power 1. Now if you have 1, that's 10 raised to power 0. So the logarithm of 1000 is 3. The power to which 10 is raised. The logarithm of 100 is 2. Because generally log or logarithm are usually in base 10, but we don't normally write that base 10. So the power to which 10 is raised is logarithm. Logarithm of 10 is 1. The log of 100 base 10 is 2. The log of 1000 base 10 is 3. So the log of 1 base 10 is 0. So this is what logarithm is all about. However, logarithm and indices they work pari passu. For instance, if we say 32 is equal to 2 raised to power something, 32 is equal to 2 raised to power something, it means how many places will 2 be raised to give us 32? Let's look at it. 2 times 2 times 2 times 2 times 2. 2 times 2 for 4 times 2 8 8 times 2 16 16 times 2 32. So how many 2 is here? 1 2 3 4 5. So it means 2 raised to power 5 will give us 32. Now if you want to find the log of 32 to the base of 2, it will give us 5. The logarithm of 32 to the base of 2 is 5. Logarithm of a number is the power to which 10 is raised. Now the logarithm in base 2 here is the power to which 2 is raised. 2 is raised to the power of 5 to give us 32. Now, let's look at another example. 64 is equal to 4 raised to power what? Say 4 times 4, 16. 16 times 4, that's what? 64. So it means 64 is equal to 4 raised to power 3. So if we want to find the logarithm of 64, we say the logarithm of 64 to the base of 4 is 3. Or we come to say 4 to the power of 3 is 64. So logarithm and indices we use them pari passu. Let's look at some questions to buttress what we are trying to say it. So in general, since we said 32 is equal to 2 to the power of 5, we said 64 is equal to 4 to the power of 3. So generally, if we have n is to the power of y, if n is equal to y to the power of x, so it means that the log of n to the base of y will give us x. So if we have, so this is the formula we use for logarithm. If n, 32, is equal to 2 to the power of 5, so it means the log of 32 to the base of 2 will give us 5. The log of n to the base of y will give us x. Let's look at some questions. Some questions here. Find x. Find x if log 8 to the base of is 3. Log 8 to the base of x is 3. What are we talking about? He said log 8 to the base of what will give us 3. So what this is saying is x, this is just simply telling us, it's just simply telling us that x to the base of 3 is 8. X raised to the power 3 is 8. So x cubed will be 2 cubed. 8 is the same thing as 2 times 2 times 2. 2 times 2 times 2. So since 3 x to the power of 3 is the same thing as 2 to the power of 3, that means x will give us 2. So our answer here will be x. So we can say log 8 to the base of 2 is 3. Another question. Solve the following equation for x. Solve the following equation for x. We have log 64 to the base of x is equal to 2. So what this simply means is x to the power of 2 equals 64. So what is 64? 64 is same as saying 8 times 8. That's 8 to the power of 2. So x to the power of 2 is equal to 8 to the power of 2. What is here? X to the power of 2, 8 to the power of 2 is the same thing. 8 to the power of 2 is 8 times 8, 64. This is it. So if x to the power of 2 is the same thing as 8 to the power of 2, the exponents are the same, so the base must be the same. Therefore, x is 8. Another question. 7 equals log 2 log x to the power to the base of log 2 to the power of x, or log x to the base of 2. So we can just simply rewrite x2 equals 7. So x will give us 2 to the power of 7. So what's 2 to the power of 7? That's 2 in 7 places. 1, 2, 3, 4, 5, 6, 7. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 64. 64 times 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. So x here is 128. Another question. Log 9 to the base of 3 is x. How do we solve it? We just say 3 to the power of x is equal to 9. And you know 9 is 3 times 3, and that's 3 raised to the power of 2. So 3 to the power of x is equal to 3 to the power of 2. Now if the base is the same, then the exponent is the same. So x gives us 2. Now, log 32 to the base of x equals 5. So how do we solve it? To be x to the power of 5 equals 32. Now what's 32? 32, what's 32? 32 is same as saying 2 times 2 times 2 times 2 times 2. 2 times 2 for 4 times 2 18 times 2 16, 16 times 2 32. So 32 is same as saying 2 to the power of 5. 1, 2, 3, 4, 5. So x to the power of 5 equals 2 to the power of 5. If the exponent is the same, the power is the same, then the base is also the same. So x equals 2. So the answer will be x here will give us 2. Solve the equation for x. X equals log 25 to the power of to the base of 5. So we can just, so this will give us 5x to the power equals 25. Now 25 is the same as saying 5 times 5, and that's 5 to the power of 2. So 5 raised to the power of x is equal to 5 raised to the power of 2. The base are the same, then the exponent will be the same. So therefore x will be 2 here. So log 25 to the base of 5 will give us 2. Log x 10 equals 5. So this question, log x to the base of 10 is 5. So it means x equals 10 to the power of 5, and that's 10. So x is to the power of 5, that's 10 in 5 places. 1, 2, 3, 4, 5. That's 100,000. Another question, x equals log 27 to the base of 9. So this simply means this simply means 9 to the power of x equals 27. Now what's 27? 27 is same as saying 3 times 3, 3 in 3 places. So 27 is same as saying 3 raised to the power 3. 3 times 3 9, 9 times 3 27. So we have 9x, which is the same thing as 3 to the power of 2 x equals 3 to the power of 3. So if the base is the same, the exponent is also the same. So 2x equals 3. X equals 3 over 2, or one whole number 1 over 2. X is either 3 over 2 or 1.5. So we express this as a base of 3. We express 27 as a base of 3, now as a base of 3. Then the base will be the same. Then we equate the exponent and look for our x. Log 5, 0.04. Log 0.04 base 5 equals half. How to solve? Log 0.04 equals r. Let's express 0.04. 0.04 is same thing as saying 4 over 100, and that's 1 over 25, and that's 1 over 5 to the power of 1 over 5 to the power of 2, and that's 5 minus 2. So we come and say log 5 to the power of this, 5 to the power of minus 2 base 5 equals r. So we say 5r equals 5r equals 5 to the power of minus 2. So r is minus 2. Log 4 to the base of 2 equals x. So we'll just say 2x equals 4. Now 4 is then the same 2 times 2, which is 2 to the power of 2. So we'll say 2x equals 2 to the power of 2. X equals 2. If the base is the same, then the exponent is the same. 25 over 5 equals x. So we say 5 to the power of x equals 25. Now 25 is same as 5 times 5, which is 5 to the power of 2. So we say 5x equals 5 power of 2. If the base is the same, the exponent is the same, therefore x is 2. Two 1/6 to the base of 6 equals p. So we say 6p equals 2/1/6. Now 2/1/6 is the same as saying 6 times 6 and 6 times 6 times 6, and that's 6 to the power of 3. So we say 6p equals 6 to the power of 3. Sorry, 6 raised to the power p, 6 raised to the power p. So if the base is the same, then the exponent is the same, therefore p equals 3. With this, we've come to the first segment on logarithm. I believe you have a nice time having been introduced to this logarithm. In the next class, we'll delve further into solving further logarithm questions. Thank you.